There's one particular attribute about the hatchback body shape that bugged me, and that was apparent when it came to adding rear wings. All my simulations suggest that the rear wings on a hatchback wasn't a great idea. It didn't really matter how far back the wing was, the performance was always far outside the wing's free stream capacity. Despite the apparent ineffectiveness of a rear wing on a hatchback, they are very common. When I say effectiveness, I mean the wing creates downforce, but the body has most of its lift restored. So depending on how much lift the body creates, the overall performance is minimal. This video will be exploring better downforce options for a hatchback. Previous simulations suggested a spoiler is better in the sense that it adds downforce without much drag, mainly due to its ability to lower the pressure underneath the floor, and it even works for rough floors. Extending the spoiler or adding winglets to the side combines the performance of a wing and spoiler, resulting in decent gains. The wings I have run behind the car have a CLA of about -0.3 and a lift to drag -3.27, very poor for a single element wing. Looking at a slice through the center of the car, it shows why the wing loses a large amount of efficiency. The lower profile on the wing can only use the mass flow that falls between the gap of the body and wing. Then this air is shed between the wake of the car and the wing. Adding to that, the angle of attack of the wing, particularly for the center section, is very high. As you can imagine, if the gap between the body and the wing is reduced, the wing becomes less effective, which I've seen in other simulations. The solution to this problem is actually very simple. Basically, it's done by separating the air used by the wing and that of the body by a spoiler. The difference is rather dramatic. 23% increase in downforce for the wing, and almost all the lift on the body is removed. Overall, the CLA went from a tiny -0.05 to a -0.46. The drag is also reduced by 10%, because the induced drag created by the body's lift is almost gone. The air is far more coherent relative to the wing, and there is a distinction between the air for the wing and the messy wake region. All I did was add a flap halfway down the rear window. I don't really know why nobody has done this before. Though that's not actually true, the current WRC cars run this setup, but then nobody has copied it. It's kind of funny because I offered this solution to a well-known early model Golf runner because they said in a video that they wanted more rear downforce. But the back and forth didn't last very long. They must have thought that I was trying to scam them. Anyway, if you're a retiree and wants to lap the Nordschleife faster, then all you need to do is fix a flap to the rear window. Now I could optimize the position of the flap and the wing, or I could find a better solution. The problem space is more rear downforce on a hatchback. The easiest way to have more downforce is by increasing the surface area. Again, we come back to the floor because that's a ready supply of surface area. Then borrowing the previous idea of the spoiler wing combo, I just make it more. And bam, 30% more downforce. The CLA is now -0.62 on a car with horrible front lift. For this setup, there is now no front lift, no front downforce, but the stock model's lift was +0.6 at 60% of the front. The body in this state now contributes 45% of the downforce, compared to 20% for the wing and window flap setup. Just a note, this solution isn't optimized. It's a design for easy fabrication, so there is likely more performance available. Overall drag comes out at almost 1, but it's just 20% more than a basic spoiler and the previous wing setup. The original idea was to have the center spoiler section adjustable to reduce drag, but then lowering it is more effective. The efficiency was reduced in line with the effectiveness of the floor, going from a -0.635 to -0.44 when lowered 75mm. For reference, the wing flap combo is -0.58.